Kirchhoff's rules, laws. Kirchhoff's rules. This is electric circuit. This is electric circuit, electric network. This is electric network, electric circuit. R1, R2, R3, R4, R5, R6 resistances, cells, EMF E2, EMF E1. This is what? An electric network, electric circuit. Suppose this is current I. Say this is I1. This is I2, I3, I4, I5. Again what? I. Because I is this current, so this will be what? Entering I, out I. Kirchhoff's rules, Kirchhoff's laws of electric circuit, electric network. Kirchhoff's first law or law of currents. Kirchhoff's first law, or it is simply law of currents. Algebraic sum of all currents at a junction. This is junction A. This is junction B, C, D. These are junction of this electric network. Junction, junction, junction. Algebraic sum of all currents at a junction of an electric network is 0. Sum of all currents here at this junction 0. 0. Sum of all current at this junction 0. 0. Sign convention. Currents coming to junction are taken as positive, otherwise negative. At this junction, the current which are coming, we have to take sum of all currents is 0. But what are sign conventions? Current coming taken as positive, otherwise negative. At A junction, there are three currents, I plus I1 plus I2 is 0. Sum of all currents is 0. There are three currents, I1, I2. Yeah, this is I1, this is I2, this is I. Three currents. Their sum is 0. What are taken positive, negative? I coming positive, negative, negative, or I minus I1 minus I2 is 0. This is what Kirchhoff's first rule. At B, now we will write directly I1 coming to junction positive, I3 out, I5 out, 0. At junction C, at junction C, this was junction C. At junction B, I3 coming, I4 coming, I out, 0. Yeah, 3 is coming, 4 is coming to the junction, and I is out, some 0. At D, this is D. Coming are I2, I5. Out is minus I4 is 0. This is what Kirchhoff's first law. कोई न्यूमेरिकल में खास ध्यान नहीं रखेंगे इस लॉ का, बिकॉज वी नो व्हाट आई इज व्हाट, कितने भागों में बढ़ गए? 2 में, I1 प्लस I2, और यही लॉ है, देखो इस पर। तो ये सीधा भी कर सकते हैं हम न्यूमेरिकल्स में। Kirchhoff's second law. Or law of voltages. Sum of or law of potential drops or law of EMFs or law of closed loops. This ACD is a closed loop. This CBDC is a closed loop. This ADB, this one closed loop. This is closed loop. Which one? AC first. This is closed loop. Second. This is closed loop. Third. It is your own choice. Clockwise. Here anti-clockwise. Both can be clock, both can be anti-clock. This can be anti-clock, this can be. It is your own choice. Make closed loops, closed paths. What is this law? Sum of all voltages in a closed path of an electric network is 0. इस क्लोज्ड पाथ में जितनी भी वोल्टेजेस हैं सम इज 0. इसमें जितने भी हैं 0. Sign conventions potential drops in same sense of path are taken as positive. Otherwise, negative. These are the sign convention. Path first. What are potential drops? VRIE, Ohm's law. V will be potential drop, voltage. RI will be potential drop, Ohm's law. E potential drop, EMF, voltage, right? You will start clockwise because you have made this path clockwise. How to start? AC. From A to C, potential drop. RI, R1, I1. Same sense of path. This is the path clockwise. What this current tells? This is what? Sense of potential drop. A to C. So positive. R5, I5. Same sense this current tells. This is the path C to D. R2, I2. This is the path. This is voltage. Opposite sense. Now This is EMF itself. We will see from this, ये RI यही है, अकेला इसी में है, ये I मीनिंगलेस है इसके लिए, दिस I is meaningless. तो ये खुद पोटेंशियल ड्रॉप है, खुद EMF. पाथ देखते हैं कहाँ आया, पॉजिटिव टर्मिनल पर. This means battery is in same sense. Sum is 0. Again listen. R1 I1 positive, R5 I5 positive, R2 I2 positive. RI खत्म. अब ये बच गई EMF. इसका कोई ये करंट कहाँ जा रहा है, इससे कोई मीनिंग नहीं है. C path. Path is at positive terminal. So it is what? Positive. Path second. यहां से चल पड़े, यहां से मर्जी है कहीं से चलिए. चलिए C to B. R3I3 positive. Sorry, it is negative. Why? This is sense of potential drop C to B, but path is in anti-clock here, anti-clock. So negative. चलिए यहाँ R4 I4. This is path. This is what? Path, and this is what? Potential drop. Same sense, same. Plus R5 I5 is 0. Look, this is the path. So R5 I5 potential drop का भी ये करंट ने बता दिया. पाथ 3. कहाँ से चले? यहाँ से चलते हैं, कहीं से भी चलो आप, लेकिन किस सेंस में ये क्या बना रखी है? क्लॉक. क्लॉक. चलिए यहाँ RI देखते हैं, यहाँ से A to B. R2 I2. Same sense. This one R4 I4. Same sense. R6 I. Same sense of path. RI खत्म. Now again, ये battery is there. The path is at negative terminal. This is the path. Here path है clock. Negative terminal minus E2. The path is at negative terminal. Minus E1 is what? 0. So this is what? Kirchhoff's rule. This is what? How to apply Kirchhoff's rule. This is electric circuit. P1 2 volt, R1 4 ohm, R3 5 ohm, E2 4 volt, R2 2 ohm, find current in 3 branches of electric network. Hence, find potential difference across CD. Say this is current I1, this is current I2, so this will be current I3 and I3 will be I1 plus I2. Because I1 is coming like this, I2 is coming, so I3 will be I1 plus I2. So we have to find what I1, I2, I3 and V across CD. Closed path first, closed path second. This is in an anti-clock, you may make it in clock. This is what? Clock, you can make it in anti-clock, both clocks, both anti-clocks, it is up to you. Apply law of potential drops at path first. B to A, Ri 4I1, B to A Ri, there is no R here. C to D, R3 I3, D to B, no R, so 0. Again, Ri, R is 0. Ri, R3, I3, R3, 5, and a battery path at negative terminal, it is 0. 4I1, 5I1, 5I2, minus 2 is 0. 4I1, 9I1, 5I2, 2. This is equation first. At path second, कहीं से चलिए आपकी मर्जी, लेकिन ये चलना है ऐसे एंड क्लॉकवाइज क्लॉक। चलिए यहां से चलते हैं C2D, R3, I3, this is I3, RI, yeah, 0, R2, I2, सेम सेंस है ये, सेम, दिस इज ऑल्सो इन सेम सेंस। सो नाउ नेगेटिव टर्मिनल is 0, 5i1, 5i2, 2i2 is 4, 5i1, 7i2 is 4. Now solve them. Multiply it by 9. This by 9. Third. And this by 5. Multiply this by 5. Subtracting, minus, this is cancelled, 8, I2, 26, I2, 26 by 38. Putting in first, nine I1, 5 I2, 2, 9i1, 2, it is I1, take 9 here, watt ampere. So one current is this, second is this, minus I3, I1 plus I2, so I3, B, C, D, R3, I3, R3, 5, I3, volt. This is electric network, electric circuit. Find this resistance capital R in this network when there is no current through EB. 4 ohm resistance किधर है? Across EB. No current flows through 4 ohm resistance. Also find potential difference across A and B. Yeah. Electric network, no current is flowing here. Find this. Also find potential difference. Now there are two closed paths. This one F, E, B, A. Yeah, this one. Another is this. कैसे डायरेक्शन दे दी मैंने, क्लॉक दे दी दोनों की, एंटी क्लॉक दे दो, एक क्लॉक एक एंटी क्लॉक दे दो. अप्लाई law of potential drop at path first. Ri, R1I, positive. Ri, here this current is I. R1, Ri, this is 0, I is 0. Now, two batteries, path, positive terminal plus 6, negative terminal path minus 9 is 0. 2I minus 3, it is 3I, 1.5 ampere. At path second, the current, no current passes through, here is I then. Ri, R0, Ri, plus 3, path minus 6, again Ri, R0, Ri, 0. So two batteries, path plus 3 minus 3 is what? 0. 1.5 R, 3 R. R is what? 6 ohm. It is 2 ohm. Now find potential difference across AD. AD resistance 2. Yeah, here is 0. Total resistance here to here is 2. PD, AD, R, I. Here to here, R is what? 2. 1 plus 1, I. I was what? 3 volt. Well, resistors. Resistance 1 ohm each form a cube. A potential difference 10 volt is applied across opposite terminals. Find current drawn from battery and total resistance circuit. These are 12 resistances. They form a cube. A 10 volt opposite corners say current is 6I, then current here will be 2I, it is I, current will be 2I, it is I, here I, 2I. Similarly, other current meaningless for us. This is closed path. Closed path. Apply law of drops. Path first. R R1 2I R1 into I 1 2I Ri minus 10 is 0. 2 plus 1 plus 2 5I is 10. I is 2 ampere. Total current, that is say I dash 6 ampere. I dash 12 ampere. VRI, here R dash, I dash. Total resistance we have to calculate. V is 10. Here this is from Ohm's law. R to be calculated, I dash R what ohm. What ohm.